Solving the impossible. How constraint satisfaction powers the future of AI. Imagine an intelligence that quietly solves millions of decisions every second, planning schedules, routing traffic, coordinating networks, and optimizing systems across the entire globe. An intelligence that doesn't need flashy graphics or massive datasets to work. Instead, it relies on pure logic. Hidden behind nearly every AI system you've ever heard of is a silent solver. Constraint Satisfaction. It's the unseen framework that turns chaos into order and makes complex decision-making possible. And today, I'm going to show you how this overlooked method is shaping the future of AI far more than most people realize. In a world where artificial intelligence is expected to make real-time decisions, optimize complex systems, and solve problems faster than humans ever could, there is one foundational method that quietly powers much of this intelligent behavior. From scheduling airplanes, assigning university timetables, designing circuits, analyzing maps, solving puzzles, to managing logistics across the world, there is a hidden engine running behind the scenes. And that engine is something called constraint satisfaction. Most people have never heard of it. Yet, it influences everything from search engines to robotics. Today, you and I will explore this powerful concept together. By the end of this video, you'll understand exactly how CSP works, why it matters, and how it helps AI solve problems that seem almost impossible for the human brain. So, sit tight, because the moment you understand CSP, you'll begin to see the world through a completely new lens. At its core, a constraint satisfaction problem, or CSP, is a problem where you are given a set of variables, a set of possible values, and a set of constraints that tell you which combinations are allowed, the ultimate goal. Assign a value to every variable in a way that satisfies all the constraints. Imagine you're organizing a small conference. You have several speakers, multiple rooms, limited time slots, and all sorts of restrictions. Some speakers can't speak at the same time. Some rooms are too small. Some topics can't overlap because they share the same audience. What seems like a scheduling nightmare for a human becomes a structured, solvable puzzle when expressed as a CSP. By turning chaos into constraints, AI systems can approach the problem logically, systematically, and efficiently. This is why CSP has become one of the most important foundations of artificial intelligence, especially in areas that require planning, arrangement, optimization, and decision-making. The key components: variables, domains, constraints. To understand CSP deeply, you need to understand its building blocks. Every CSP consists of at least 3 major components: variables. These represent the elements you need to decide. In a scheduling problem, your variables might be speaker A's time slot, room assignment, topic placement. Each variable is something the system must determine, domains. These are the possible values each variable can take. For example, times 9 10 11 Reinhold halb, room C. Domains tell us what is possible before constraints are applied. Constraints, these are the rules. They define what combinations are allowed and which ones are impossible. For example, speaker A cannot be scheduled at the same time as speaker B. Room C can only fit 20 people, so large events can't be placed there. Beginner and advanced sessions can't run in parallel. Constraints are what shape the problem. They transform a simple list of options into a meaningful puzzle. Once these 3 pieces are defined, AI begins searching for a combination that satisfies every rule simultaneously. And that's when things get interesting. How AI solves CSP, from brute force to smart search. Let's imagine trying to solve a complex CSP manually. Suppose you have 10 variables, each with 5 possible values. That's already 5 more than 9 million possible combinations. And that's just a tiny problem. This is where AI comes in. AI doesn't simply try all possibilities. Instead, it uses intelligent strategies to narrow down the search space, eliminate impossible paths early, and home in on valid solutions quickly. Some of the most common techniques include backtracking search. This is the backbone of classical CSP solving. AI assigns values step by step. If it reaches an impossible situation, it backtracks, returning to earlier decisions and trying new options. It's like exploring a maze. If you hit a dead end, you retrace your steps and take a different path. Forward checking. Here, the AI checks ahead, removing values from future variables whenever a choice would violate constraints. This prevents wasted time exploring doomed paths. Constraint propagation. This technique spreads constraints across variables, reducing the available values early. One famous algorithm that uses this approach is the AC3 algorithm, which ensures constraints remain arc-consistent. Heuristics. AI uses clever rules to decide which variable to assign first or which value to test, such as minimum remaining value MRV degree heuristic, least constraining value. These dramatically speed up the process. Local search. Instead of searching systematically, AI jumps around the solution space, improving solutions iteratively until it finds one that satisfies all constraints. That's the beauty of CSP. Multiple strategies can be combined to solve problems quickly, even when the possible combinations are astronomically large. Real-world example: map coloring. To make CSP more concrete, let's walk through a popular example: map coloring. The problem is simple. You need to color a map so that no two neighboring regions share the same color. The variables are the regions on the map. The domain might be 3 colors: red, blue, green. The constraint: adjacent regions can't have the same color. This might sound trivial, but as the map grows countries, provinces, districts, the number of combinations explodes. CSP allows AI to solve this efficiently by analyzing relationships, constraints between regions, and reducing the search space. The map coloring example is not just a textbook problem. It reflects real applications such as frequency assignment for radio towers, territory segmentation for logistics, resource allocation in distributed systems. This is why the map coloring CSP is often the first step to understanding the real complexity behind industrial optimization. Why CSP matters in AI today. CSP is more than just an academic topic. It's an essential tool used across industries, technologies, and scientific fields. Here are some areas where CSP quietly powers core processes: scheduling and planning. From airlines to hospitals, scheduling thousands of tasks with hundreds of constraints happens through CSP frameworks. Robotics. Robots performing complex tasks must satisfy spatial, temporal, and structural constraints. Network optimization. Routing data through crowded channels involves constraints on bandwidth, latency, and signal interference. Artificial intelligence decision-making. AI systems often need to choose from many possible actions while satisfying moral, legal, or operational constraints. Game solving and logic puzzles. Sudoku, crosswords, cryptographic systems. Many of these are classic CSPs. Supply chain and transportation. CSP helps optimize routes, delivery timetables, and resource distribution. In short, CSP is everywhere, even though we rarely see it. CSP as a foundation for the future of intelligence. As AI becomes more advanced, CSP becomes even more important. Modern AI must organize massive numbers of decisions, handle millions of constraints, and do all of it in real time. The future of CSP includes integration with machine learning, use in autonomous vehicles, large-scale logistics optimization, smart cities and traffic control, adaptive scheduling for global operations. CSP is not flashy. It's not the AI that writes poems or generates images, but it keeps the world running. It is the intelligence beneath the intelligence, a silent problem solver that powers many of the systems humanity depends on. Understanding CSP means understanding a core pillar of artificial intelligence. And that is the power of constraint satisfaction problems. They're not just puzzles, they are the framework that transforms chaos into order. allowing AI to handle the complex decision-making that defines modern life. If you want more deep dive AI content like this, make sure to like the video, subscribe, and comment on what topic you want next. Let's continue exploring the hidden engines that make AI truly intelligent.